Hello everyone, we're the Hantas, and today we'll be covering hantaviruses.
Jeanette,
Gabby, Sam, Raquel,
Gary.
First, we will begin with the basic features of the hantavirus. The hantavirus belongs to the Bunya family. It is enveloped and has a heliconucleocapsid structure. It is a single-stranded negative sense RNA virus with a diameter from 80 to 120 nanometers. Now we will look at the hantavirus's genome. Its genome consists of 3 single-stranded RNA segments. The larger L segment is between 6.8 and 12 kilobase pairs and encodes the L protein, which functions as the viral transcriptase. The medium or M segment is between 3.2 and 4.9 kilobase pairs and encodes a polyprotein that is co-translationally cleaved to yield the envelope glycoproteins G1 and G2. The smaller S segment is between 1 and 3 kilobase pairs and encodes a nucleocapsid N protein. Some genome features are an overlapping reading frame that produces a non-structural protein, NSS, to function as an interferon inhibitor. Also, the viral genome contains non-coding regions that are responsible for forming a panhandle structure that functions as a viral promoter and are crucial for transcription and translation.
So, with the basics covered, we can now start going over the replication and transcription of hantaviruses. So, as you can see from the image is the full hantavirus cell cycle, so we can briefly start going over each step. So at step 1, hantavirus attaches to receptor on the cell surface, which triggers a signal transduction. At steps 2 and 3, the signal transduction enables viral entry via receptor-mediated endocytosis. The type of vesicle that hantavirus uses is the clathrin vesicles, which is coded as clathrin-mediated endocytosis. So more specifically, this is known as clathrin-mediated endocytosis. So after the clathrin vesicle is formed, the clathrin coat is uncoated inside the cell, causing virus particles to be free. Once the virus particles are free, they travel to the early endosomes, which gradually mature into the late endosomes, and this promotes further propagation into the cell for the virus. After the early endosome matures into the late endosome, this results in the fusion of viral and endosomal membranes via acid-induced conformations. So the acid-induced conformations, they enable the fusion of membranes, which promotes the release of ribonucleoproteins, or RNPs. These RNPs are transported to the Golgi, so while they're being transported, this is thought to be where viral transcription is occurring. Once the ribonucleoproteins reach the cis Golgi, this is thought to be the site of viral replication. So after replication, virus particles bud from the cis Golgi to the plasma membrane to promote viral survival. So at the plasma membrane, this is the release where the virus particles are released to the surrounding environment.
now that we have gone over the replication and transcription of the hantavirus, we will be going over the transmission and infection of the virus. Hantavirus is spread when virus-containing particles from rodent urine, droppings, or saliva are stirred into the air. It is important to avoid actions that raise dust, such as sweeping or vacuuming. Infection occurs when you breathe in the virus particles. Rodent vectors in the U.S. that carry the hantavirus are rodents such as the cotton rat, the deer mouse, the rice rat, the white-footed mouse. These can all be found in the U.S. or in Central and South America.
Created using Powtoon.